Hello, Miss Larry, Mr. Ryan, are you right? Are you right? Okay, so let's say we have an array with positive integers only. Okay, so ideally these positive integers cover the 1 to n and 1 to n, you know, and there could be duplicates. So for example, like 2, 4, 3, 2, 1. Okay, for example, this. So an array containing the positive integer, and we're given a k. K, for example, equals 3. Okay, let's say k equals 3. So with one operation, we can remove the last element, the rightmost element, and put it in your collection. You know, just collect it like 1. Okay, so the next one is 2. The next one is 3. And the minimum number of operations we need to remove the last elements from the right is 3 in order to get all the integer from 1 to k. So 1, 2, 3 up to k. For example, k equals 3.
What if you can't get all of them?
Very good. If we can't get it,
Like there's 1, 2, and then 4, and then 3.
yeah, if we can't get to, then return -1. Okay. So for example, like, you know, given this array,
You could just sort the. You could
That's
just sort it.
okay. So let's
No,
see.
you could just go to the back and then sort it. Find k and then to the right, sort it. And if there's
Sort it,
sort it and then reverse it. And
and reverse.
if-
I don't get the question.
Okay, let me explain one more time. Okay, Eric, that's good because I was not explaining very clear. Okay, I feel it that way. Okay, so we have an array of integers.
Ding ding!
Please,
Jingle
please.
bells, jingle bells.
We have an array of integers and we have a k. So with one operation, we can remove the last element from the array. Okay, so the question is, what's the minimum number of operation you need to remove in order to get all the numbers from 1 to k? For example, if k equals 3 is, I need to get all the numbers
Doesn't need
1,
to be-
2, 3. And how many operations?
Does it need to be consecutive?
Which part is consecutive?
1 to k.
1 to, oh, very good. No, it doesn't have to. You can get a 3 to 1 as long as we have all those numbers. So in this case, it's 4 because 1, 2, 4, 3. We just need a 1, 2, 3, this number, right? The minimum number operation we need
What's
is
the
1, 2, 3.
solution to that?
Sorry?
What's the solution to that?
K equals 3.
No, but that array thing. Yeah, you said the solution. What was it? You were saying, oh, it was like 4 or something, and then you're like,
Yeah, because we need the 4 operations to get the 1, 2, 3, right? You have one operation, you get 1. You remove 2, you have 1, 2. You remove 3, you don't have 3 yet. You remove 4, then you have 3. 1, 2, 3. Okay?
so you can have like numbers in between.
That's right. Yeah. Okay. So let's look at another example.
Another
For
piece of
example,
cake.
a piece of cake. I like to hear that. For example, like if I have these 5 here. So let's say if I have replaced this is 1. So how many, when k equals 2, how many operations?
3.
Well done. How about if k equals 4, how many operations?
You can't do it.
-1, yes. How about k equals 2, how many operations?
3.
That's right. Okay, you get that, right? Now you get it.
You
Okay,
already
so
asked if k equals 2.
You
You just check.
you detect where the numbers are, and then you just do it.
we just do it. What kind of data structure we need to use to
Counter, I think.
counter?
I'm gonna counter you.
Okay, counter.
How about 2-pointer?
How can we apply component? No.
Set.
Set. Yeah, hash set. Because we want to remember.
Dictionary.com.
We want to use the set to remember the numbers we've seen, right? And let's say because all these, right? We know when we're given a k.
Yes.
We know what numbers we are looking for. For example, given k equals 3, we know we are looking for the numbers 1, 2, 3. Okay? So we can perform a scanning from right to the left. Okay, so we have a set, right? We have a set. Now, we have set. If k equals 3. Okay? 5. This is not the number we're looking for. We skip. 2. This is the number we're looking for, right? So we put it here, set 2.
Why don't we use
1.
the projector?
Can you just like
Why can't we use the projector?
Too noisy. Okay, 1. This is the number we're looking for. Put it here. 3. This is the number we're looking for. 3. Okay, every time we check the size of the set. The size of set is is k equals k, then we simply return how many operations? 1, 2, 3, 4. Am I right? Yeah, makes sense?
Yeah, but you can do 3 because 2, 3, 1 from the left.
That's right, but the question is from the right.
But that's boring.
That's very good. That's very good. Because we can only do it from the right hand side, so it's boring. There's only one possibility. But if we revise the problem to say, okay, let's say, what if we can remove from the left hand side? Yeah, we talked about a similar problem days ago, right? Remember the consecutive, we can remove, what's the maximum? Do you remember the question a few weeks ago? What's the question again? What's the minimum number operations, right? If we can remove the elements from the left or right. And then the reverse of it is what's the maximum subarray of a given sum? So this question is simple because we can only remove it from the right hand side. Okay, so we just do this process as we talk.
Go through it. Just go through it until you have all of the numbers.
Yes, well done. Yes. Or if we use up all the numbers, we return -1, right? So we just use the set. Set contains only unique. So for example, why this is important? So for example, if I have an extra 1 here, okay? So 5, we don't put it in a set. 2, we put it in a set because it's less than k. That's all equal than k. 1, we put it here. Another one, we don't do anything actually because this element is already in the set. And the set only stores 1 copy, unique number, right? So it doesn't do anything. And then 3 here, then each time we check the size of the set. If it's equal to k, then we know we already collected enough numbers, then we can just simply return how many steps, right? Okay, let's implement this. Simple, right? It's very simple, right?
That's it for the day, guys. Bye-bye.
Okay. Array, okay. We want to iterate from right to the left, right? So we can use this for, let's say, set equals set, right? This is how we define the set. For I in range, we start from the last one at length a minus 1. Index starts with a 0, so the last index, the first index we need to try is length the -1, right? And then the last element is 0, -1, the step -1. If ai is smaller or equal than k, if this is the number we're going to collect, then s dot add ai. Once we add it, we need to check if the length of the s is equal than k, then return the length of the array minus I, right? Minus I. That's it. Okay, and if we can't find anything after the for loop, if we can't find anything after the loop, we just return -1. Okay, simple, right? From I, we start from the rightmost index to 0. Step -1, right? The range function, this is a star and step, right? So start from the look 1, 2, 3. Okay, this is the array. Start from here, ends at -1, but not including -1. So it actually ends the element before that, which is 0. Step -1 because we are decrementing instead of incrementing. If we don't specify the third parameter, the default is 1. Okay, star stop step. Then we check this number. Check the number. If it's less than k, if it's the number we want to collect, then we add it to the hash set. Then we check. When we add it to the hash set, we check if the size is equal to k. Like if it is, we return. For example, like if after collecting this, we have enough numbers, then we return 2 steps, right? Length is 3. 3 minus this index is 1. So 3 minus 1 is 2. 2 because we collected 2 elements. The time complexity, you should be pretty good at this.
When?
Yes. Because we are just iterating over. Our n is the number of the elements in the array. What's the space complexity?
O-N.
Because we're using the set. We're iterating over the index and we don't want to get a value, and we can use a function. What is the function? Start with E. What function can we use?
Enumerate.
No, this one is
Enumerate.
enumerate. Oh, well done. Okay, enumerate. So instead of this,
Shift 6.
Instead of this, we can enumerate. Okay, so I'm going to write the enumerate function. We are enumerate from right to the left. We need to reverse it, right? Yeah? Enumerate. So for I, V, this is the index, this is the value. In reverse the array, right? We want to reverse it because we are iterating from the right to the left. We need to reverse it. And we just check if V, right? The AI using the enumerator. Okay, we need to enumerate here. Enumerate, reverse that. Then if V is smaller than K, then S dot add V. Then here is the same. If length S is equal than K, then return what? Return I plus 1, right? Because I start from 0. If the first element, collecting the first element, we already collected enough, then we need to return 0 plus 1, which is 1 operation, and return minus 1. Do you get it? These two, the same idea, just different implementation. This one is based on enumerate because we use the enumerate, right? Enumerate returns a tuple, I, index, and a value. Okay, and because we want to use the enumerate, we have to use the reverse iterator. We want to reverse it, right? For example, this array is 1, 2, 3. We reverse it to become 3, 2, 1, right? You know how to reverse a array a list. 2 pointer. How do we reverse 1, 2, 3 to make it 3, 2, 1?
Column minus 1.
Well done, color. Another way is that we use the 2 pointer, right? We swap. So 1 and 3 swap and move it together until they meet in the middle. Okay. Okay, so to sum up, today we given this problem, we given an array, and we given a k. With one operation, we can remove the elements from the right, and we want to find out the minimum number of operations that we need to do this in order to collect the k elements, which is from 1 to k. The solution is just to use the simulation from right to the left. All right. Okay, Eric, Ryan, what have you learned today? That's it.
Me?
Yeah.
We have this area of K. We want to find it from right to left. We want to find it how much you need to find all the numbers lower down, no, up to K. And if you can't do it, you return -1.
What's the solution? Yeah. So what's the idea? How do we solve this problem? What's the idea?
Just going through it until you have all of the numbers you need.
Okay. And what's the data structure we need to use to?
Set.
Okay. That's it for today. Bye bye.
Set before they
Good job. Bye bye.